Welcome, cloud enthusiasts! If you learned something new from this video, share it with your friends. Don't forget to subscribe to the Cloud Enthusiast channel and hit the bell icon never to miss new videos. In this video, we will explore the reliability pillar of AWS Well Architected framework. After this video, you will learn design techniques and best practices to architect a reliable environment capable of enduring resource failures. Let us understand reliability using a car analogy. A reliable car breaks down less often, and it can alert you of any upcoming problems so that you can get it fixed before the car stops working. Similarly, a system's reliability can be assessed by its ability to avoid failures and to recover quickly from a failure event. In the cloud, reliability is dependent on the resources used to build the architecture. From the application user's perspective, an application is considered reliable if it is available when needed and is working as expected. Therefore, reliability of an application can be measured in terms of its uptime. So if you are building an application with an uptime of 99.9%, that means it will be unavailable for 8 hours and 45 minutes each year. Similarly, uptime of 99.95% will be unavailable for 4 hours and 22 minutes each year. An uptime of 99.99% will be unavailable for 52 minutes each year. And uptime of 99.999% will be unavailable for 5 minutes each year. Architecting a reliable solution is difficult and expensive, especially in traditional data centers. However, the cloud provides the ability to spin up resources when needed by treating them as code. Therefore, achieving the desired reliability is much easier, especially when automation techniques are used. This makes it one of the driving factors for organizations to embrace the cloud. Let us review some of the traits of a reliable architecture. Define. Before you start working on the design, you need to understand the application's reliability requirements based on the business objectives. Reliability is often at odds with the cost. Therefore, you have to find a balanced approach when architecting. During this phase, architects need to determine recovery time objective, or RTO, which is the maximum acceptable time it takes to recover from a failure. In other words, it is an acceptable downtime. And recovery point objective, RPO, which is the maximum acceptable time duration since the last data recovery point. This determines what is considered an acceptable loss of data between failure and recovery. Reduce impact. Once you understand the business requirements, you have to architect the solution to minimize the impact of failure. Suppose you are running a web server that requires 8 cores of CPU. Instead of using a single EC2 instance with 8 cores, use 2 EC2 instances with 4 cores each and divide the workload amongst them. This strategy can help avoid the single point of failure. In case one instance fails, the other can keep the application running until the system recovers to full capacity. To protect against availability zone failures, you can provision each of these instances in a separate availability zone. And to protect against the entire region failure, you can set up multi-region deployments. This is especially useful for mission-critical applications. Elasticity. Using cloud services like auto-scaling, you can build elastic architectures that can withstand varying loads by automatically scaling up and down when needed. This way, you do not have to over-provision or under-provision the resources. Monitor. The most critical step in creating a reliable system is monitoring anomalies and triggering an alert if a problem is detected. Therefore, having adequate monitoring and alerting mechanism is an essential part of any reliable architecture. CloudWatch is an AWS service that provides comprehensive tools for monitoring and alerting purposes. Recovery. Monitoring and alerting coupled with automation can enable a system to recover from failures without human intervention. For example, CloudWatch and autoscaling can be used together to recover from failed EC2 instances. Similarly, RDS can be used with CloudWatch to trigger a failure event if the master database fails and shifts traffic to the secondary database automatically. Backup. Backing up data is essential for the continuation of any business. In an unforeseen event of losing the master copy of your valuable data, you can always restore it using the backup copy. Therefore, backup your data periodically using services like Amazon S3, which provides 11 nines of durability by replicating your data across multiple availability zones. Your recovery point objective defines how often you should back up your data. Testing. Traditionally, testing a system was limited to the extent of verifying its ability to work under normal conditions. In contrast, you can simulate various failure scenarios using the cloud tools and services and validate the recovery process. For example, you can stop an EC2 instance and verify that the autoscaling event launches a new EC2 instance. Change management. Changes to the production environment need to be automated so that the system can be rolled back easily in order to restore functionality if the deployment is unsuccessful. CloudFormation, AWS Config, and Code Deploy are some of the tools you can use for change management. Limits. Resources are available in the cloud when you need them. However, certain limits are imposed on the services that you need to account for while architecting. Some are soft limits and can be easily increased by contacting AWS customer service, while others are hard limits that need to be considered during the design phase. AWS Trusted Advisor can be used to review the service limits that apply to your account. You can also set up notifications via CloudWatch alarms when you're about to hit the limit. Following these principles will help you design reliable architectures. Managed services like S3, DynamoDB, and Aurora offer built-in resiliency and should be preferred. Comment below to share how you made your applications reliable.